In this lesson, this is Mod 8, Lesson 3. We're going to look at the distance formula and how it's related to slope. If you remember from earlier in the mod, we looked at the slope formula. So remember, our slope formula is m equals y2 minus y1 over x2 minus x1. Again, it doesn't matter which point is point 1 or point 2 as long as we're just consistent with how we solve the problem. What we're also going to look at is how we can maybe see the relationship between slope and finding the distance between 2 points. So for example, if I have 2 points right here, or if I want to use kind of a version of the Pythagorean theorem, which is the distance formula. So the distance between 2 points is the length of the line segment that connects them. All right. Our formula that we're going to use for distance formula comes from the idea of the Pythagorean theorem, right? So if I have form a right triangle on my coordinate plane, if I essentially find the length of the two legs, which is kind of similar to how we find slope, right? Those change in y and change in x, I can use that to find the distance, which is essentially the hypotenuse of a right triangle that I form. So our distance formula we're going to end up using is x2 minus x1 squared plus y2 minus y1 squared. And if you notice, it actually looks very, very similar to our slope formula. So our slope formula, we have y2 and y1s. You're going to see the same subtraction there. And then same thing if I look at my x2 and x1, x2, x1. So we're going to see that repeated subtraction take place. And if you're asked to do both slope and distance, it can sometimes make the problems go a little faster. All right, for our first problem, it asks to find the slope and the distance between 2 points. So I'm going to go ahead and write my distance formula that we just talked about a moment ago. My distance is equal to, and then I have x2 minus x1 squared, and y2 minus y1 squared. Okay, so if I look at my point, I can call this x1, y1, x2, y2, and then to find the distance or the length between for the two endpoints of that segment, I'm going to go ahead and just substitute those values in. Keep in mind the subtraction is actually part of the formula. So when I look at this, I'm going to write these squares. I have a subtraction sign. And then now I could just substitute my values in. So I have my x1, 2, and x1. So that's going to be 8 minus negative 11. And then my y's are negative 6 minus negative 11. And then we can go ahead and simplify that out. So I have the two subtractions become an addition, same thing here. And then when we go through and solve that out, we're going to end up with 19 squared plus, and then negative 6 plus 11 is going to be a 5 squared. 19 squared is going to end up giving us 361. 5 squared is 25. So we add the values first, so we're not going to take the square root of each piece by itself. We're going to put them together first and get 386. And then finally, our distance or our length of that would be 19.6 units. Now, for the slope, again, that's just kind of the same thing as before. So these are actually like two different problems using the same coordinate points. So when we go ahead and use our slope formula, what we might recognize is that we have the subtraction, again, for the y2 minus y1 is the same that I did right here. So I got that to be 5 before I squared it. So if I want to save a little bit of time, I can actually recognize that the y2 minus y1 is going to end up being 5. If that's something that you didn't catch, you can always just start the problem over again. That's fine. But again, it's just something to note to make the problem a little easier. Same thing with x2 and x1. I actually already did that math. That's the same as 19. So I can actually make that a 19 because again it's the same as the ones we just saw, and then our slope here would be 5 over 19. All right, for our next problem, again, this is kind of the same as before. So if we look at it, we actually have that we're using, again, the same, we have two different points that are given, and it's asking for the distance as well as the slope. So I'm going to go ahead and write my distance formula here again. So d equals the square root x2 minus x1 squared plus y2 minus y1 squared. I'm going to go ahead and label this out. So x1, y1, x2, y2. And then when we go ahead and substitute those values in, it's going to, again, it's going to look kind of the same as the last problem. I usually like to tell students if you write the parentheses with the subtraction, it helps to remind you that the subtraction is part of the formula and that you're going to subtract and then square. So our x values are 12 and 6. Our y values are 19 and 1. And again, you can go ahead and write it where you write the x1 and x1 then x2. If you're still, you want to keep it in the same form as the formula, that's fine too. So if I wrote it the other way around, I could have even x minus 12, 1 minus 19. And then we're going to go ahead and simplify that out. So we'll have here negative 6 squared plus negative 18 squared. Remember, when you square, you're going to get a positive value. So when we go ahead and square that, we're going to get 324. Oops, sorry. You're going to get 36 plus 324. We're then going to put those together and get the square root of 360. And then our length is going to be, we get 18.97. So if I round it to the nearest tenth, it'll be about 19. Okay, so that would be the distance of units between those 2 points, or that's the same as if I found the length of the segment formed with those 2 points. Okay, if I wanted to do my slope, again, slope, your formula is y2 minus y1, x2 minus x1, but you can save yourself a little time if you notice that you already did y2 minus y1, and you already did x2 minus x1, right? You did them right here and right here. So if you want to save yourself a little time, you actually already see that this would be negative 18 over negative 6, or you would get a positive 3. So your slope is a positive 3 over 1 or a positive 3. All right, for this next problem, we're going to have you try the same thing where you're determining the slope and the distance given different points. And here is the slide with the answers to the you try problem worked out. All right, for this next example, we're going to find the slope and the distance using a graph. So when we go ahead and take this segment, we're going to treat that like the hypotenuse of a right triangle. So I'm going to go ahead and connect this, make a right triangle here, and then determine the length of each of legs. So if I go ahead and look at this first one right here, I have a length of 4. I'm actually going down 4, so I'm going to put -4 just so I remember it when we talk about slope. But if I'm talking about the length of that segment, that length would just be 4. Same idea for when I'm going from left to right. So if I actually count it out, I'm going to get this to be 6. And so if my question is asking for the slope, my slope would be rise over run. So it would be a -4 over 6, or a -2/3. If I'm going to do my distance, again, this is just a fancy way of doing Pythagorean theorem. So I actually have that this would be a +6. This would be a -4. And then I'm going to go ahead and square it and then square root. So I get 36 plus 16. We're going to get the square root of 52, or 7.2. And then that would be my distance and my slope. Next problem, we're going to have you try the same thing where you're finding the slope and the distance using a graph. And here's the slide with the you try problem worked out. If you have any questions from this section, feel free to reach out for help or sign